The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, wherever you are in the world. Welcome to the DataView show. This is episode number 14. I'm your host, Scott Hayes, lifetime IBM champion, IBM DB2 Gold consultant. And today we have a super special guest with us. I'm certain many of you may know him. He's a frequent speaker at iDoug. He's a blogger. He's an IBM DB2 Gold consultant, and he's an IBM champion. It's none other than the amazing Dave Beulke. Dave, how are you today?
Thank you, Scott. Yeah, I'm good. Everything's good. Hope everybody's staying safe out there.
Right. Washing the hands for 20 seconds. I heard it takes 20 seconds to sing the happy birthday song in your head twice. And then there was a little bit of Texas humor going around that I saw. It says, urging everybody to wash their hands as if they had just cut up jalapenos and they were about to take out their contact lenses.
Yep, that's a good one.
Yeah, you don't want to play with hot peppers. So welcome, everybody. And today we'll be talking about SQL performance best practices, especially as it relates to big data, but I'm sure Dave's going to have some great general SQL performance tips as well, because he's that kind of guy. Here's the required gibberish. The opinions expressed are that of Scott Hayes and the show guests and do not necessarily reflect that of IBM Corporation or the IBM community. DB2 is a registered trademark of IBM, which is also, incidentally, a registered trademark. And IBM actually has many registered trademarks, and we make no claims to any marks belonging to anyone. This event is being recorded and replays will be publicly available. Please mind your manners. Also, people frequently ask if they can get a PDF of the guest presentation, and we will make a PDF available during the last 10 minutes of the show. You'll be able to download that from GoToWebinar. We'll also make a PDF available in the show replay blog. So you'll have two chances to get that PDF. Now, what's ahead? Here's what we're going to do today. We're going to have Dave's fantastic presentation. Get him going right away because he's excited to present to you. And then we'll give Dave a little break. He can sip his favorite beverage. We'll have some news bits. We'll get Dave back on to finish his presentation, ask a couple polling questions. We'll do thank yous. If you have any questions throughout the show, use the GoToWebinar question answer tool. Send your questions over. We'll get to some of the questions during Dave's presentation, and maybe we'll hold a few to the end as well. And with that, Dave, it's time to make you our presenter. I'm going to click my button.
Sounds good. There we go. And presentation mode. Come on. There we go. See my slides okay?
I see your screen. I see your name in a big blue box.
Excellent. So here we are, advanced SQL performance tips for big data. This is a presentation that talks about all the things that I've been recently doing with very large tens of billions of rows in the database. The things that I'm talking about today are ZOS, but the principles that I'm talking about in the SQL facilities that I'm using to get the performance are also applicable in the LUW environment. So that's me. I've been around forever. I've been doing DB2, ZOS, and LUW, and spoke at all the conferences over the years. I'm a consultant. I've been independent since the 90s, so I'm old.
Dave, you're not that old. You're trying to liken yourself to a dinosaur.
Well, the things that we're going to talk about today, it's all about getting your report or your answer set or whatever you want as fast as possible. And the things that I'm going to talk about are a huge parallelism. And I'm going to run all this SQL against the zip processors on the ZOS environment. So this is going to cost you less and less CPU for your general process. And the things that I'm talking about is in use today and in use several years ago against some of the large 50 billion row databases that I've designed and implemented. And big data is not a problem for DB2, ZOS, or LUW. You can do these things and it won't cost you anything because it all runs on the zips. So SQL tips, start with the basics. Make sure that you only select the columns you have, only the rows you need, where is using an index column, reference all the tables, code the where clauses, and make the DB2 engine filtered faster. There's wonderful Java programs that people say that they can do it faster, they never can. Why is my thing not advancing? There we go. Prioritize the where columns. Make sure your most restricted where is the first in the where clauses. Do your joins. Always, the join is always faster than an application join. The SQL joins, make sure that they're used off of a common index column or a group of columns. And if you don't have an index, go talk to your DBAs and maybe they can make one for you.
Hey, Dave?
Yes.
Did you see that thing on Twitter? I saw a really clever idea. You had on your previous slide, you had a select star. And
yes.
And the guy said, here's what you do to prevent people from doing select stars. You alter the table and you add a column that would divide by 0. Makes the SQL blow up, right? You're not going to do a select star anymore, friends.
Exactly. The other thing is use all the DB2 functions because they do the operation much faster than your than any application program or any outside report writer. Make sure that you understand what report writers you're working with. I was working with clients that use Tableau, use Spunk, use all sorts of business objects types of projects. And when they click around and they generate every single column within the report, those GUIs are really a troublesome situation. So make sure that you review all the SQL that ever is produced from them. Make sure that it's only getting the information. Also, make sure you're doing your joins against index columns that have statistics run on them. And column frequencies are very, very important. We'll talk more about run stats and those things later on in the presentation. Also, many people are having multiple databases, multiple tables within one LPAR or one instance, and they're defining the DB2s, one as EBCDIC and one as ASCII. Also, they're doing all sorts of cast substring and case statements. All of these things down your SQL, and you want to make sure that you filter that stuff out. Make sure you understand the order of joins. A sort is a 4-letter word. Make sure that you understand all the things in your SQL that makes work bad. We have the Harry Potter sorting. Sorts can kill you many times within your SQL and within many query blocks. Some of the big SQL that we're talking about today have 92 query blocks because they have union all joins that do many different things against many parts of the database. So sorts are very much a killer, and you really want to make sure that you pay close attention to any of those special words in your SQL that might cause this. Again, you want to make sure that all your SQL is indexable. Way back when, scalar functions were indexable. Those have improved as more function levels of DB2 come out in version 12. They always seem to take care of something else that wasn't indexable. It's now indexable. Make sure that you do a good explain against your current environment so that you understand things that are indexable and which ones aren't. Also, I've seen SQL where there's math formulas within the SQL itself. Try to take that out, because as the data goes through that SQL statement, it has to be transformed, and that slows your SQL down considerably. Also, I've seen ORs put in where clauses. ORs have a tendency to make things into table space scans, or can be a non-matching index scan. Try to change those ORs to subqueries. That will definitely potentially improve your SQL performance, and also make sure that you never have a table space scan. Understand the number of trips to the database. This is for a lot of the C, Java, and machine learning people. They seem to want to get new sets of data all the time. If you're going to be coming after the data, make sure you're using multi-row select and inserts. Way back when, I did a whole bunch of retail systems for a company I used to work with. And one of the big successes that we did is we created common table expressions for everything. And what that did is we created that CTE that gave us all the orders to process today. It was one massive CTE that was used throughout the day for all sorts of reportings. It was great for making sure that everybody was included in what everybody knew, what was being shipped out and worked on in the warehouse and everything else. CTEs are a wonderful thing. Just like several years ago, I did a system for a large medical environment that had billions and billions of rows also. For their billing, we created a large number of CTEs, but we also created materialized query tables that were refreshed on a daily basis. Between CTEs and MQTs and using temp tables, these are, I can't endorse them enough. If a database or a set of data is going to be used more than 3 times, you definitely want to look at the design option and the overall performance of creating. CTEs can really make your life a whole lot easier, but you got to make sure that you're going to use it. And the general rule of thumb that I use, that if that set of data is used more than 3 times, it can really save you a lot of performance. The other aspect is number 23, creating indexes on expressions. If you have, again, an expression that is common within your business or common within your processing, you want to look at that expression and making an index out of it. One of the great features of DB2 is you can create an index over any expression almost, and I really endorse that also. The other thing that talking to the application developers that sort of bugs me all the time is not everybody understands the wealth of information that can be found in all the various explain tables that we have in that list there. And all the things you can do to prototype your environment and prototype the performance that you're going to get. Creating virtual indexes is really good for testing out your indexes on expression, the uniqueness, index definitions, if you move columns around, if you only include columns, things of that nature. All of these explain tables tell you what DB2 is thinking when it's looking at your SQL. And you need to look at all these sys feedback tables, the sys column disk table, all of these different tables that give you information about how DB2 is. Now, there's a whole lot of DB2 vendors out there that sell great tools that interpret some of this stuff and put it into English for you. Those tools also work out very nicely. So either use your tooling that you have, but make sure that you get all the full information out of these explain tables. You understand exactly what your SQL is doing. The other thing is, one of the things that I really don't like to do, but if you have a nullable column, try to make sure that you exclude the null values from your index. Verify the nullability is not within the application. Try to avoid nulls. I'm not a fan of nulls whatsoever, but sometimes they're from legacy applications or from other considerations, and you have these issues. So try to avoid the nulls as much as possible. Also, making sure that you understand when DB2 is going after your table, you can look at the DSN predicate table, and this will give you the information of how the optimizer is thinking about your different access paths and things that are happening within your overall performance of your. Again, there's a wealth of information that can be looked at through these various tables, and I encourage you all to do. The other aspect is when you're doing performance for large databases, every little thing adds up. When you have 1 billion rows, 1 in a million happens an awful lot. So you have to maximize all your performance and maximize the parallelism within your CPU, your storage channels, your buffer pools, your I/O hardware, and understand all your table space parallel information. Do this by making sure that you have SQL that doesn't have withhold or is bound with repeatable read or RS. Having a brain meltdown. Read stability. And you want to make sure that you verify your buffer pool parallel sequential, and also that degree of any is allowable within your environment, and also that your DB2 subsystem degree subsystem parameter is turned on. Within my blog on the website, back in version 10, I did a 5-part blog series on enabling parallelism within your ZOS environment. A lot of that still applies, but you want to make sure that you define all of this information and take care of it. And you want to make sure, if you have the opportunity within your database design, to create hundreds or thousands of partitions over your big table. Because through the partitioning, you're going to be able to influence your SQL to do parallelism And to do that through all your tables that are in a join group, have similar partitioning keys and partitioning, and have equal partitioning limits, ranges. Also, within the big data, the billions of rows, we're going to be using our data sharing members to run multiple jobs on multiple LPARs at the same time to maximize execution across the data sharing environment. We're doing reports mainly for this type of situation, so we don't have any locking across members or buffer pool consideration. But that enables us to do multiple parallel processes within each LPAR. One of the things you also have to understand is how many jobs that you can run within your ZOS LPAR. Some people have multiple machines. Currently at my lab, I have a Z15 across my various LPARs, but in other environments I've worked, I've had Z15s on some LPARs and Z14s on other LPARs, and you have different number of different amounts of memory, different Java memory allocation issues, number of initiators, workload manager issues, and also the most important thing, number of zips that you have available, because that's where we're going to run all of our SQL. And if you're not familiar with using union all occurrences within each SQL statement, that is another key point for parallelizing your SQL. We also make sure we collect statistics. Run stats is very, very important. One of the things when I was doing this presentation is there's a full migrator process that can be done to capture all the statistics that are in your production environment and take all of that 4 million or 5 million lines of SQL or SQL DDL that migrates to your environment, take all of that and create a test database with define no and all your column group and all your statistics from your production environment, and use that in your test environment so that you get a full understanding of what the access paths you're going to have. This is a really good way to collect all the frequency and cardinalities, all the column groups. One of the things that I see clients do occasionally is manually try to do this manually in a test environment. There are so many statistics and so many interrelated statistics within this. If you manually update your DB2 catalog statistics, you may have unpredictable access paths. So really, really try to stay away from that. I always try to collect statistics against any part of the database with every execution of a utility, so I can avoid the cost of running standalone run stats. The other aspect, when you're running run stats against these large tens of billions of rows, your sampling is very minimal because of just the process would be CPU intensive and killer for collecting all the stats. But your sampling is make sure your sampling is effective to get you good access paths for your production environment, and again collect the stats for everything that you can. Also pay special attention. It always seems that when I'm trying to get a new report request, it's always got a LOB or an XML column that I need to grab from one of the tables. So there's always some fly in the ointment. And what I really like to do is keep the XML and the LOB access to the very, very last query block. And that way I know I'm only getting the absolute minimum rows from the LOB or the XML that I'm doing. So what we're going to do is we're going to create an XML statement that is referenced in the very, very last query block. And that's takes some shifting around of SQL and moving things around, but that's when you have to reference XML and LOB columns. So what we do with the SQL is we create a CTE that gives us all the SQL and all the report information, and we're going to drive that CTE to make sure it answers all the business requirements of the environment, and we're going to use multiple jobs that execute the CTE with multiple union all statements across the entire table spaces range. And then we're going to run jobs across all the data sharing environment using the different LPARs and using all the zip processors that we can. That's the way we get performance. I've given you 46 tips that have worked out very nicely for me for this big SQL. Tony Andrews has a great book from IBM Press on DB2 SQL, and he's got, I think, 100 tips there, and it's a great book. So, Scott, time for a break?
Sure. Dave, put that picture of Tony's book back up, because that's a great segue.
Okay.
I have a question from Carol in the audience while I transition to me being the presenter.
Okay.
Carol would like to know, I'm seeing a lot of not, not this, not that, not something else. I'm not sure how to avoid this, although maybe a table with a subtype for group of codes that are positive. What is your advice on not?
Using not in an SQL statement can sometimes cause you performance issues. I try to work with SQL and using equal situations as much as possible, and try to look at what is going to be in the report as opposed to what's not going to be in the report. I know that's difficult, and it all goes back to your business requirements, but try to work with equal conditions as much as possible and work with large filtering aspects when you're going against the SQL.
Thank you for that response, Dave. Keith wants to know if a PDF is going to be available. We announced at the beginning that we will make a PDF available via the GoToWebinar tool. You'll be able to download Dave's PDF during the last 10 minutes of the show. We'll also make Dave's PDF available in the replay blog, so you'll have 2 chances to get Dave's handout. And someone else in the audience would like to know where you are during this lockdown.
I'm in Florida. I'm at my house in Florida. It's a wonderful place to be sequestered. It's beautiful.
Are you hanging out with the alligators or what?
No, I try to sequester myself on golf courses on the weekend.
Oh, that sounds pretty tragic. I guess you could maintain social distancing easily on a golf course.
My slice tends to do that.
All right. So what do I have next here to share? A little bit of news. Upcoming shows. On the 9th of April, our next show, we're going to have the All About iDoug show, which was originally scheduled to be June 7th through 11th in Dallas, Texas. But that event is going to be postponed. We're going to have the show anyways, because iDoug would like to have the opportunity to tell you about this amazing conference. And there's a lot more to iDoug than just the North American conference. There's European conferences, Australia conferences, online content, the premium memberships, and all that. So we're going to do the show on iDoug, and we're going to keep everybody updated on when there are new dates for that iDoug conference. And maybe in a subsequent show, we'll let the iDoug folks on again to give you some news and updates. But do tune in, learn about iDoug, and maybe it'll help you make a compelling case for why you'll want to attend later in the year. On the 30th of April, we're going to have DB2 11.5 news and updates with Carrie Romanofa. She's the chief architect of DB2 in the IBM Canada lab, and she's a great presenter. And looking further ahead, I don't have them on the show schedule yet, but on the 14th of May, DB2 ZOS version 12, Best Developer Features by Tony Andrews. And Dave was just showing you a picture of Tony's book. That'll be a great show focused on DB2Z. 21st of May, we're going to have a really cool presentation from a gentleman in Ireland about cybersecurity and some of the IBM technology that's involved in implementing cybersecurity best practices. 4th of June, we're going to have a show on IBM replication, data delivery in 2020. That's with IBM Gold consultant Frank Fillmore. So save the dates and register. We'll get the newsletters out too. Some of my favorite URLs to encourage people to visit. There is community.ibm.com. Join the IBM community if you haven't. Lots of great information and discussions there. There's a new DB2 GUI, the Augmented Data Explorer. You can download it and use it for free. There's the URL to go get your copy of that cool tool. IBM Think has now gone virtual, at least that's the plan. And if you go to ibm.com/think, you can register, and the plan is all the education and sessions is going to be free, and free education is a wonderful thing. There's a new DB2 console. It's going to replace Data Server Manager. You can get that at ibm.biz/db2 console. Informix is still alive and doing well. Learn about what's going on with Informix at iiug.org. iDoug.org, register early and save. I imagine that early bird registration discount might be extended, and if you register now, they will roll your registration forward to the rescheduled dates. And another favorite thing here, there's a cool tool I learned about, the Watson Auto AI. Look into this, click on that URL there. Well, you can't click on your screens, but go to ibm.com/cloud/watson-studio/auto AI and get a copy of that tool. You just upload a spreadsheet or give it a data source, and it'll tell you things about your data that you didn't know. It's pretty cool. All right. Ask the audience. I think I have one polling question. Select a poll. How did you hear about today's show? This is where we check in with the audience, Dave, make sure everybody's awake. Move the mouse, click on a button,
Yep.
and respond. Stuart just updated me, said the Think is 2 days, and it is free.
Awesome.
Free is a really good thing, free education.
Yeah. I might be doing my JSON presentation.
All right, let's close the poll and share the results with everybody. Oh, no, wait. We don't have 80% yet. Going once, going twice, closing the poll, sharing the results. Here's the answers. Of the people that are awake and paying attention to their screens, didn't do much Twitter promotion for this show, but we still caught some. We got LinkedIn. The DataView show newsletter was the most popular source for today's show, and 30% learned about it from the IBM community and the DataView show homepage. So there we go. That's how people found out about you today, Dave.
Cool.
And we'll save another polling question for the end. We're going to ask people if they learned anything today, and I'm going to give a high probability that people did learn things from you because you're a super presenter. All right.
Thanks.
Let's get you back on the air. I'm going to make you the presenter.
Sounds good. Okay.
Can see your screen, ready to roll.
Okay. Statistics. I talked to everybody about how to take my grader and do statistics. That's a huge opportunity. One of the things you want to make sure that you understand when you're dealing with billion row tables is you create that test environment, but you need to understand unique things about the environment. Where's your biggest table? Where's your smallest billion row table? Where's your clustering? What are your partitioning scheme and your range limits? And most importantly, when is there maintenance or availability for that large database? Again, I went through the hell of trying to have a database compare EBCDIC and ASCII, so I always try to mention that. That is a very, very bad situation, and you try to get away from that as quickly as possible. Also, if you're going to have any SQL performance success, you want to try to minimize the long varchars and the varchar columns that are out there that seem to be all over the place. So you want to cut those down or substring those or trim those immediately, if at all possible, within your environment. Also, make sure that you're using big ints when you're using billion row tables, because overflowing and integer is always there. But the biggest thing you want to do is you understand the uniqueness and the partitioning that's going on within your environment, because that's where you're going to be able to divide and conquer and get the performance out of your environment.
Dave, let me inject for just one quick second.
Okay.
A member of our good-looking audience asked when you can to clarify if you're talking about LUW or ZOS, or if applicable to both. I think generally you're applicable to both, but do highlight if it's one platform or the other.
Yes, everything that I just said on that last slide about uniqueness and partition by range is available on DB2 LUW now. It all works out great either way, and that design principle I've used. I was doing a large internet ad marketing system where we did about 300 million in about 2.5 hours on a DB2 LUW system that worked out fantastic for the client. And you know, that same principle of understanding your partitioning schemes and the uniqueness of partitioning schemes works out very good. The other thing that you need to understand is all the indexes. One of the big successes that I had with the medical system was including 2 extra columns in one of their main partitioning indexes. It took us a long time to schedule the availability for that change, but we were able to realize better overall performance through the inclusion of those 2 extra columns within that partition thing. Gave us more cardinality, more flexibility, and you really want to make sure that you emphasize the partitioning columns in all of your big SQL that you're doing. One of the things that you want to make sure when you get into these large environments, use DIPSI indexes as much as possible, because they allow better parallelism, because there's more data sets, and the parallelism within the DIPSIs is much better than a NPI. Also, when you start to look at your business criteria, you need to translate that all into the where filters. Now, when you start out with possibly tens of billions of rows, you want to understand what columns are involved, where the duplicate data is, and calculate your result set. When talking to the business all the time, it seems that they always want to try to boil the ocean. You want to make sure that you understand and they understand that you want to get to a situation where you give them valuable data, and giving them counts of situations and counts of various business criteria is usually much better than giving them the detail of that information. But if they want the detail of that information, you need to understand what columns are absolutely necessary, and if and how you can fit that on a 4K page, because that's your optimum sort type of situation. But you want to determine what is the most restrictive business criteria or where clause that you can have. And you want to start with that where clause that's most restrictive in your where clause and in your SQL, because that will knock down the number of rows for all the subsequent query blocks that you have. And you have an SQL statement that has 30 query blocks in it. Cutting out as many rows as possible right off the bat makes all your subsequent rows perform faster, all your subsequent query blocks execute faster and better. Again, I try to use equal conditions with all my criteria wherever possible, and try to use stay away from or statements and use all the indexable where clause criteria that I can. Very positive about using case statements, subqueries, left outer joins, all that kind of stuff that is indexable, and get that into your where clause. Reduce the rows immediately, join the smallest, biggest table that you've got, because I have, in my environment, I have a 12 billion row table that gets joined to a just slightly under 1 billion row table consistently. So I try to join those two tables as much as possible and let the smallest table drive the business criteria in the first join. So that reduces my answer set by giving the business criteria to that 1 billion row table, and drives it even more restrictive than that. So I know after the first query block is executed, my answer set that I'm doing in subsequent query blocks is much less than hopefully 500 million rows. So also look at what common criteria you have through referential integrity, and what join group of tables can be used with like indexes. So if I have to reference a third table or a fourth table through those billion rows, I try to filter all of those in a massive chunk in that first query block, if at all possible, doing a 4-table join, and have that filtered as much as possible, and putting all the business criteria for all 4 of those tables immediately in that first couple of query blocks. Reference tables and other things that may be related, do that in exist type of situations or in other filtering later on in other query blocks. Non-index stuff, again, stick that if you can at the very end, because it's not going to be an indexed column, and you're going to probably do a work file scan. So if you can filter that data out with an index, that's great, but in some instances, you want to keep that filtering to the very last query block, much like I talked about earlier with XML and LOBs that you're working with. Now here, this isn't a picture of Pac-Man, but this is a picture of how you should understand your database and your various tables. Here's my red is my big circle set of my large billions and billions of rows. The green is the other table that is going to restrict. The white is my possible answer set, and the other little colors, the small circles, are the filters that I need to grab out of that white. So demonstrate and diagram your business criteria for everything that you're going to go after. And doing this type of paper exercise and knowing your data and knowing the rows that are affected is very good to understand where the most filtering is going to be happening and what is going to be happening within your query situation. The other thing is sorts are bad. Sorts are rescanning information that you've already scanned, and that's why I have a picture of a 10-pound bag. Now, all of our systems on DB2Z and DB2LUW, sorts are the limiting factor on a lot of these large systems. Because all the group bys and all those keywords that give you sort, you want to make sure that you minimize using any of those if at all possible. Know which data and know which query block is going to be doing a sort. One of the things that's great about doing sorts, if you have to do sorts, is you want to make sure that your sorts are reflective in parallelism. And you want to leverage the table clustering sequence by ordering your SQL or putting an order by the clustering sequence. Sometimes you can get away and avoid a sort completely, but still have things in a clustering order. The whole idea here is you want to avoid sorts as much as possible. There are good filters and bad filters. Make sure that you're filtering your data as much as possible. And in those DB2 Explain extended explain tables that I talked about, you can get detailed information of how your filters are being used within your SQL statement and how DB2 is interpreting those. This can also help point out where the varchar comparisons and where you should not use substring unless it's at the first column because it's not indexable. Avoid using calculations, what I talked about earlier. EBCDIC, ASCII conversions are bad, or converting things from character to varchar. Timestamp conversion, XML parsing. Do good filtering by using equal signs on numeric data or character comparisons against full character situation. Now, I talked earlier about common table expression, and if you are unfamiliar with common table expressions, basically you are creating a table of information out of an SQL statement and using that query, that common table expression set of data multiple times. So one of the things I talked about earlier were the daily tables, where all the daily information for all the orders was being kept. The other thing that's really good is by creating a CTE, you can create multiple reports by state, by product category, by product price, by order amount. You can do it by customer demographic. You can do it by customer loyalty. You can do all sorts of things. So creating CTEs from a join group of the business requirements is a wonderful, wonderful thing, and that should be your first step for creating things. The other aspect is know your database and know the partitioning limit key ranges. Here are two ZOS catalog SQL catalog queries that you can use to get to limit ranges on the limit keys that you have within your environment. We're going to need that so that we can know the partitioning limit keys and we can align the partitioning keys within our SQL. By doing that within our SQL, we can get parallelism within our DB2 SQL, both on LUW and on ZOS. The other thing is, when you're working with these large databases, you need to pay extra close attention to where the table spaces, the index spaces are within the buffer pool. Memory is a wonderful, fast performance enhancer item, and you want to make sure that you understand what buffer pools are assigned to what table space. It took me a while. It seems that I've had this issue with several clients over the years, that they have multiple high performance table spaces where they're always referencing that table space, and they have it generically within one buffer pool, or they don't have it separated out to maximize the buffering that is available. You want to make sure that your main billions and your biggest tables have free memory usage. So defining exclusive buffer pools for some of these large tables, make sure you're not mixing indexes and table spaces, because they have different IO patterns and different retain. So this is a way to understand your buffer pools versus your table space, and your buffer pools versus indexes. One of the things when you get into this high performance parallelism, you can dunk or flood a buffer pool very quickly with one table's information. So you need to be able to make sure that you can push that information through the buffer pool very effectively. When we did performance analysis on one of our previous databases, we saw that they didn't have a good alignment of the buffer pools versus the table spaces and index spaces. So we had to move things around and straighten that out. Also, know the sort limits, and know the sort limits for each of your, if you're working in a DPF or a EEE environment on DB2 LUW, know the sorts limits on each particular node. On ZOS, know it on each DB2 member, because it's hopefully defined the same, but it always turns out that it's different, it seems like. Make sure that you have enough DB2 sort work area. And also make sure that you're running within your schedule, so that maybe that your big SQL can dominate that sort area. This is where I talked earlier about making sure the report can fit in a 4K page. Well, if your query blocks go through a situation where they're greater than the 4K, then they're going to have to use bigger sort areas. And what you want to do is, when you explain your SQL and when you have subqueries or left outer joins, and you have them associated with the parallel partitioning scheme that you've got, you can get massive parallelism within your sorts that are within your query block. When we were doing our first performance aspects of the SQL, we were looking at getting 24 parallel streams within our environment by doing our parallel access across multiple tables, across multiple partitions at once. So being able to get that information in parallel, getting that information in our query blocks, and unfortunately sorting it, we were able to get huge amounts of parallelism. We got so much parallelism, and we were dominating the zip processors so much, is the system programmers took the toys away from us and now limit us to an 8-way parallelism within our sorts and within our high performance SQL. So it's very vital that you keep things and understand the 4K sort optimization that you want to try to do. One of the things also that you want to look at is validate your workload manager settings and validate them against an LPAR and a DB2 system. Understand how many zips were available. We had a lot of zips available and we were getting a huge amount of parallelism, but we were taking them so much that we got in trouble, and now they only allow us 8 parallel across the different LPARs. The parallelism, know your SQL, that's 1 TCB, and how many SRBs, how many subtasks you are limited to. Know the number of processors that are available on each LPAR. Sometimes they focus those on particular LPARs within environments, or make sure that you understand whether you're on a Z14 or a Z15, because the number of cores that comes into those different systems has different topology. And here, this chart that I stole from John Berg is a great chart talking about what is the different memory configurations of a Z15 and how you get more. You get 12 cores and much more memory on a Z15. Again, anybody on DB2 LUW, DB2 ZOS has the fastest 5.2 gigahertz processors and the most L4, 3, 2, 1 memory that's associated with a chip. So we can do things on the ZOS platform that are much more efficient than some of the LUW, even the cloud situations. When I started this presentation, I thought I was going to be detailing a lot of Spring Batch. One of the things I'd like to say now is you want to try to maybe avoid Spring Batch, because the Spring Batch architecture of read, process, and then write concept doesn't get as much parallelism through the JVM and through the chunking process that they've got. If you're trying to do Spring Batch and you're doing updates, you really want to be careful of where those updates happen. Because what Spring Batch does is it takes your process, chops it all up, and tries to run it in parallel across many processors, across many pieces of the system, both on ZOS and LUW. If you have a updating process, you have the ability to have one process being running and locking up another Spring Batch process. So you want to really be careful with that. The other thing is, when we looked at using Spring Batch, we had to do a lot of tuning of the JVM, because within each of the processes that they have within their chunking system, you have to adjust the amount of data and the amount of work that's being done so that you can understand what's going on within that various chunk. Again, you're going to dominate a CPU per JVM, and you probably want to have one processor per JVM. So again, you're dominating processor and you don't really have that type of a situation where you can share processors. So within the Spring Batch environment, you really don't get as much parallelism as you can with just a pure DB2 SQL type of a situation. The other thing is, we've been looking at putting our Docker and our Kubernetes environment on, and what we've looked at is, this is a great red book that just came out that explains all the information that we've been going through. But if you're going to do a Kubernetes and Docker type of a cloud, you can do it very easily in a Unix or a Linux environment, Ubuntu on ZOS 2.4. And this is the environment that same type of thing, the secure services container environment that IDEA works on. And it's a platform where they deploy IDEA and you deploy other Docker deployments. Again, this maximizes the zips in your Linux environment, and it's great. One of the things that they highly recommend is having one zip processor for the Docker process itself, and one per database per process that's going on. So you'll have a major node for the LPAR, and then you'll deploy Docker images to that underlying node within your Kubernetes type of deployment. So what this looks like, if we're going to try to mimic the parallel environment, I've got an 8-way data sharing system. I need to have one zip processor per LPAR, and I want to get 8-way parallelism, so I need 64 zips for each particular LPAR, and then I do that across 8. So I need 128 zips to replicate my existing ZOS performance that I've got. So it really looks into the number of processors is cheaper to do it in a native DB2 ZOS environment. So one of the things you want to do with your high performance billions of rows is get all the business requirements in your CTE SQL. Do all your table joins, your outer joins, the where join criteria, all the business filtering, and hopefully you're ordering by the clustering sequence. You want to get all of that business criteria into one CTE, designed it, tested in a small test environment, validate all the business requirements, make sure that you understand all the query blocks that are happening, make sure this is where you move the SQL around so that you get the most restrictive business issue first, and you reflect efficient business access. So get all the business issues settled in a plain old CTE. Then the next thing you do is you take that CTE and you create a partition group of it, where you have a partition range on each of the CTEs. So in this CTE, we have a master CTE that sums up all the other CTEs that are within this union all structure. By having that union all structure, we're able to get not only massive parallelism within one of these CTEs, but simultaneously, we can also get DB2 concurrently executing the subsequent CTEs and getting all the zip processors. Now, when we first tried this, we went a little overboard, and we had a union all that went after 8 situations. Here we have 4. We had 8 SQL CTEs. That was a little burdensome, and it caused the SQL not to be as efficient. We cut it back to 2, and then we went to 4, and that's where we were able to maximize our parallelism of 8 that we were allowed. This also optimized the sort utilization and the parallelism properties that we have. So we have multiple jobs that go against multiple sections of the partitioning range that filter this out and parallelize it to give us the answer set and the numbers of the various reports against the tens of billions of rows that we're scanning to get this information. That is how you can scan, how we scan over 35 billion rows in under 6 minutes.
Dave, this is something you're very passionate about. We're about out of time though, so it's time to get to the end.
Here is a summarization of the different steps that I've gone through and I've explained. You can go through that. The pot of gold is getting it to run in the 6 minutes. Monitor your statistics, monitor your information, and reiterate it. Rewrite, reorder, make sure you have clear IO streaming, because sharing buffer pools is a bad thing, and know where your business logic is being done, and reiterate and rewrite the SQL. Thank you all for your attention, and thanks for your time today. Back to you, Scott.
Fantastic. And there's a few questions in the question queue.
Okay.
There's a fellow named Abrar that's actually asked several of them. I'm gonna throw them all at you. Here we go.
All right.
Are there any limitations to run on time schedules? How is it compatible with cross-platform softwares or OSs? How is the growing landscape complexity handled? Or if there's incremental and data volumes analysis execution, how are these obstacles handled? I think Abrar is your new best friend. Also, how is the hardware workload handled as it's distributed depending on occurring situations? Please let me know. And several people have given you compliments and kudos in the questions as well.
Oh, cool. Well, to address his questions, you have to dig in to, if you're working in an LUW environment, or if you're working in a ZOS environment, you have to work into the installation of the DB2 system and what parallelism was enabled when the system was installed. Get with your system programmers or your SAs and understand what they did, or look at the system and look at those various parallel settings. Then also, you know, as I talk about buffer pools and things of that nature, understand the mapping of your memory against the physical database objects that you've got, the indexes, the table spaces, and all those things, and see where, again, your parallelism settings are within the DB2 environment, and what things are being shared and what things, because you can't execute huge parallelism if you're stepping on yourself through the memory configuration and trying to share CPUs and things like that. On LUW machines, they're always sharing processors, and it may be that you're in a VM environment. Try to go bare bones and stay away from VMs on LUW, and get, you know, the processor and the memory assigned to your DB2 system, and you can improve performance tremendously.
All right, lots of questions and a comprehensive answer. Well done. There was somebody earlier that asked about the last used on the indexes, and they say if last used is, you know, indicates an index has never been used, and they drop an index because there's fear about dropping indexes. What is your opinion on last used? And I think this would be applicable to both Z and LUW.
Yeah, last used is great information. And what I've done in the past when I've tried to clean up databases is I've not deleted the index, but I've stopped that index, and stop it for 3 months and see if anybody tries to reference it. You know, the last used will give you that information, but also by taking it and stopping it, You can also find out if somebody's using it that way. I'm trying to minimize. I was at one client where they had 14 indexes on their main processing table, and it was just incredible, the performance improvement we got when we consolidated some of those indexes and made some include columns. It was great. So yeah, I highly recommend consolidating indexes or eliminating or stopping them to find out when you can finally delete them.
All right, Dave. Well said. Well said. And I distributed the poll question earlier, asked people if they learned anything. Now sharing the results. 97% of today's huge audience learned something from you, and 3% have probably seen you present before. So that's great.
The 3% were the guys from IBM.
Yeah, exactly. So I'd like to thank everyone for being here. Hope everybody stays safe, stays home, cuddles up with their favorite blanket. Thank you, Dave, for being our guest today. Really great presentation.
Thank you, everyone.
Thank
you, Scott.
Sponsors, the IBM Community has made today's show possible. And your replays and show news are going to be at dataviewshow.com/news. And we'll put that handout in the replay blog as well. And with that, that's the end of the show. It's a really good one.
Thank you very much. Take care.
Yep, you too. Hope that your golfing goes well this weekend.
I hope so. I hope so. I'm isolating myself with my slice. It's sad.
Go get some hole-in-ones.
There you go.
That'll minimize your time on the course and your exposure.
Exactly. Take care. I'll talk to you soon. Thanks, Scott. Can you send me any of the questions in the chat?
Yeah, I think you got them all. If there was any that were missed, I'll send them along separate.
Okay, cool. All right, dude.
Yep.
Talk to you soon.
Yep, bye-bye.
Bye-bye.